And the craziest part? Last year, over 60% of AI ML projects never made it to production. 60%! Think of all that wasted compute.
Wow, that's staggering. So we're talking about a massive graveyard of models that looked great in a Jupyter notebook but crumbled the second they faced real-world data.
Exactly. And with the rise of agentic AI, these autonomous agents making decisions, taking actions, the stakes are even higher. It's not just about a bad recommendation, it's about potential cascading failures if these agents go rogue.
Rogue agents. Okay, that sounds like a sci-fi movie. But seriously, what are the real-world consequences? What happens when these agents, designed to automate complex tasks, start making bad decisions at scale?
Think about a supply chain management system powered by agentic AI. If the agent misinterprets demand signals or reacts poorly to a disruption, say a port closure, it could trigger a bullwhip effect, leading to massive shortages or overstocking. We're talking millions of dollars in losses, not to mention reputational damage. Or imagine an agentic AI trading bot. A single bug could bankrupt a firm in minutes.
Okay, I'm officially scared. So it's not enough to just build a clever agent. We need to ensure it's behaving as expected in a constantly changing environment. That's where observability, guardrails, and evaluation come in, right?
Precisely. Think of it like this. Observability is the dashboard, guardrails are the seatbelts, and evaluation is the crash test. You need all three to confidently put your agentic AI car on the road. Let's start with observability. It's more than just logging errors.
Right, because with traditional ML models, you're often focused on model performance metrics, accuracy, precision, recall. But with agentic AI, you're dealing with a series of actions and decisions. How do you even begin to observe that effectively?
That's the million-dollar question. You need to track the agent's entire decision-making process. Think about logging every input, every thought process, if you can get to it, every action taken, and the outcome of that action. It's about building a complete audit trail. Netflix does this really well with their recommendation algorithms. They not only track what you watch, but also why the system recommended it to you.
Okay, so Netflix tracks the lineage of a recommendation, but how do you then surface meaningful insights from all that data? Just logging everything seems like it would create a data swamp.
Here's where it gets interesting. You need sophisticated tools that can correlate actions with outcomes, identify patterns, and detect anomalies. Think about using causal inference techniques to understand why an agent made a particular decision. Did it overreact to a specific data point? Was it influenced by a noisy signal? Tools like Honeycomb or Lightstep can become invaluable here.
So it's about moving beyond simple monitoring to understanding the causal chains within the agent's decision-making process. That makes sense. But what about guardrails? How do you actually prevent these agents from going off the rails in the first place?
Guardrails are your safety net. They define the boundaries within which the agent is allowed to operate. Think of them as rules that constrain the agent's behavior. For example, you might set a guardrail that prevents an agentic AI pricing system from raising prices above a certain threshold during peak demand. No more surge pricing gouging.
Easier said than done, right? Because these agents are designed to be autonomous. How do you balance autonomy with control? If you over-constrain them, aren't you just negating their benefits?
That's the tightrope walk. The key is to define guardrails that are specific, measurable, achievable, relevant, and time-bound. Smart guardrails. For example, an agentic AI customer service bot might be allowed to resolve simple queries autonomously, but it should always escalate complex issues to a human agent.
Okay, escalation protocols as guardrails. I see. Are there any specific techniques or frameworks that companies use to implement these guardrails?
Absolutely. One popular approach is to use reinforcement learning with human feedback, RLHF. This allows you to train the agent to stay within acceptable boundaries by rewarding desirable behavior and penalizing undesirable behavior. OpenAI uses RLHF extensively in training their large language models. This helps steer the models away from generating harmful or biased content.
That makes sense. So you're essentially teaching the agent the rules of the road through reinforcement. But even with the best observability and guardrails, things can still go wrong, right? That's where evaluation comes in.
Exactly. Evaluation is your final line of defense. It's about rigorously testing the agent in a variety of scenarios to identify potential weaknesses and vulnerabilities. This isn't just about running offline simulations. You need to evaluate the agent in a live, production-like environment.
But how do you even measure the success of an agentic AI system? It's not like you can just look at accuracy scores. The goals are often more nuanced and complex.
That's a great point. You need to define key performance indicators, KPIs, that align with your business objectives. For example, if you're using an agentic AI system to automate fraud detection, you might track the number of fraudulent transactions prevented, the false positive rate, and the time it takes to resolve a fraud case.
So it's about defining metrics that capture both the effectiveness and the efficiency of the agent. What about more qualitative aspects, like user satisfaction?
Wait until you hear this. Some companies are using techniques like red teaming to evaluate their agentic AI systems. They hire external experts to try to break the system by finding loopholes or exploiting vulnerabilities. It's like a cybersecurity penetration test, but for AI.
Wow, that's proactive. So you're essentially simulating adversarial attacks to uncover hidden weaknesses. That could be incredibly valuable, especially in high-stakes applications. But doesn't that get expensive?
It can be, but the cost of not evaluating your system thoroughly could be far greater. Think about the potential damage to your reputation, your bottom line, or even your customers. And there are less expensive options. A/B testing different agent configurations in production, for example. Even shadow deployments, where the agent's decisions are observed but not enacted, can reveal critical insights. Uber does this constantly when rolling out new routing algorithms, comparing the proposed routes to the routes drivers actually took.
So constant iteration and testing are key, but here's what I'm still grappling with. How do you handle situations where the agent's behavior is unexpected, but not necessarily wrong? What if it discovers a novel solution that you didn't anticipate?
That's the million-dollar question. This is where human oversight becomes crucial. You need to have a process in place for reviewing and validating the agent's decisions, especially when they deviate from the norm. Think of it as a human-in-the-loop system. The agent handles the routine tasks, but a human steps in to handle the edge cases and the unexpected situations. This is how Amazon often handles complex fulfillment logistics. AI proposes the optimal solution, a human reviews and approves or modifies it.
So it's not about blindly trusting the agent, but about augmenting human intelligence with AI. That makes a lot of sense. It's a partnership, not a replacement.
Exactly. And that brings us to the practical takeaway. What should software engineers do differently after listening to this?
Okay, 3 actionable things. First, start small and iterate. Don't try to build a fully autonomous agentic AI system overnight. Begin with a narrow use case and gradually expand its capabilities.
Second, invest in observability from day one. Don't wait until things go wrong to start tracking your agent's behavior. Build a comprehensive monitoring system that captures all the relevant data. Think instrumentation first.
And third, embrace a culture of continuous evaluation. Regularly test and validate your agent in a variety of scenarios, and be prepared to adapt your guardrails and your evaluation metrics as needed. Treat your AI agent like a growing child. Constant supervision.
I love that analogy. So to sum it all up, Agentic AI is incredibly powerful, but it's not a magic bullet. It requires careful planning, rigorous testing, and constant vigilance. Think of it like building a self-driving car. You need to ensure it's safe, reliable, and responsible before you unleash it on the road.
Couldn't have said it better myself.
Agentic AI. Great power, great observability.